Welcome to Ask and Learn.
So we are given this function, and this is the domain that the textbook gives us. So the intercepts for this are every pi n, we're going to see an intercept, but that's not inside of our domain, so let's disregard that. And we're going to have 0, 0. That is in our domain, so let's write that down. Symmetry, it is an even graph, so we'll see symmetry there. And asymptote, it's every pi over 2n. We'll go ahead and write that in because even though it's not included in our domain, just so that we can visualize a little better. So pi over 2n, every pi over 2 times, an integer, we're going to see an asymptote. All right, so I'm going to start the graph. So let's say this is negative pi over 2. And this is pi over 2. And remember that pi over 2 is the asymptote that comes along with the tangent graph. So pi over 2 and negative pi over 2, that's our bounds for the domain. All right, and we already said that we do have an asymptote there. So everything within the asymptotes, we're going to have our graph within here. All right, and now to see where it increases and decreases, we'll find the first derivative. So y prime equals tangent x plus x times secant squared x. All right, so that's our first derivative. And let's find the second derivative while we're at it. So y double prime is equal to 2x secant times secant squared x tangent x times tangent x plus 2 secant squared x. All right, so those are our derivatives, and now so this is the first derivative, so f prime. So I'm going to test for increasing and decreasing between the bounds that I have. So between negative pi over 2 and also our intercept, so let's put that on there, 0. So let's see what's going on there. And pi over 2. And since we know the intercept, let's just plot that. So 0, 0 is our intercept, and it is also a point on our graph. All right, so now if we test points here into the first derivative, anything between negative pi over 2 and 0, it's going to be negative and therefore decreasing. Anything between 0 and pi over 2 is going to be increasing. So that's our first derivative test. All right, and now let's look at the second derivative. So this is f double prime. And let's look at the same, between the same numbers. So negative pi over 2, 0, and pi over 2. So plugging in values into the second derivative between negative pi over 2 and 0, it's going to be concave up since it's positive. And here as well, it's going to be concave up. So because there's no sign change, it's not an inflection point, and it's always going to be concave up between the interval negative pi over 2 and pi over 2, and that's not included. All right, so that's a second derivative test. So what we know is that it's before 0, it's decreasing, and then when it hits 0, it's increasing, and it's always concave up. So we know that it's gonna look something like this. Decrease, it's gonna be decreasing, hit our intercept, and then increase, and it's always gonna be concave up.